Okay, problem 3. That's your standard form, your general form, and really you're going backwards here. They're giving you the general form, and they're asking you to find the center, so you need to put it in the standard form and the radius. Once it's in standard form, it's pretty easy to see. Then graph and the intercepts, or the intercepts and then graph. It doesn't really matter the order there. Okay, we start out with our basic equation here. And you have to complete the square. That's one of the reasons I emphasize completing the square. X squared minus 2x, we group the x's together. Y squared minus 8y, the y's are grouped, move the constant term over. Completing the square for the x, half of this 2 is 1 and 1 squared is 1. I add 1 right here to make that a perfect square on the left. I have to add 1 on the right. Completing the square for the y group, half of this 8 is 4. 4 squared is 16. I add the 16 to make this a perfect square. I have to also add it on the right to keep the equation in balance. Since we were making this into a perfect square, that means it should be some binomial squared. The square root of the first term, the square root of the last term in that group, middle sign quantity squared. Check it by multiplying them together and doubling it. Did you get the middle term? Yes, we did. With the y, square root of the y squared, square root of the 16, middle term is negative. Put a negative sign. If you multiply those together, you get negative 4y. Double it, you get negative 8y. When you combine all this, you get 36. This is your standard form, so now it's easy to find your center and your radius. Your center would be 1, 4. It's the opposite signs. Notice that. The radius is the square root of 36, which is 6. Now, we want to find the intercepts, both the x and y intercepts for this particular equation. To me, it's easier to use this form by far than to go back and use the general form. Okay, well, if you want intercepts, to find the x-intercepts, you let y equal 0. So that turns that into a negative 4, and when you square it, you get 16. 16 from 36 leaves what? 20. If you really wanted to put that one in, you could put that step in. It might improve from that. What is it actually going to be? Let's adjust this and make this the actual 20 here. So you've got x squared equals 20. You want the x minus 1 squared equals 20. You want the x minus 1 by itself. You want to get rid of this square first. So you're going to take the square root of both sides to eliminate this, but you have to allow for the plus and minus here. This negative 1 can be moved over, but the 20 has to be broken down in, remember, 4 times 5. I did it over here. Square root of 4 is 2. So that becomes 2 on the square root of 5. These are your two x-intercepts right here. Same thing is true with the y-intercepts. We let x be 0. This becomes a negative 1 squared, which is 1. And 1 from 36 leaves 35. Take the square root. Then you would have y minus 4 plus or minus the square root of 35. 35 does not contain any perfect square factors. So these are your two y-intercepts right there. That's a list of all your intercepts. First two being x-intercepts, the second group being y-intercepts. This is your graph. Notice that it does not come out with the radicals, but your My Math Lab, and Ms. Carr also likes it, for the intercepts to be in this radical form. Simple radical form is the way we like to leave a lot of things in mathematics. So you have to understand those radicals and how to break them down into their simple radical form. You can't just grab it off of the graph like we can for a lot of things.